Load the GIS App 1 project from the last tutorial. Open the planned default camera in the upper right view. Save the project as GIS App 2. Let's revisit the Hydro 100K metadata file and look for stream-specific information. The fifth paragraph under Entity and Attribute Information describes a stream-specific attribute of interest. Order is the Strahler order of the stream and ranges from 1 to 7. First-order streams at the highest elevation are usually the smallest bank-to-bank and the most steep and erosive. Where two first-order streams join, a second-order stream is created. Two second-order streams joined form a third-order stream, and so on. Where a lower-order stream joins a higher-order stream, there is no change in stream order. For example, when a first-order stream joins a second-order stream, the stream order remains unchanged. Lower-order streams are tributaries of the higher-order streams they feed. It may not be obvious, but stream order can help us create Terraffector streambeds. Lower-order streams are smaller, rougher, and tend to be more V-shaped in cross-section. Higher-order streams are wider and tend to be more U-shaped. Once again, metadata has provided us with unexpectedly useful information. Launch the Import Wizard. Go to the DVD Data folder and load streams.shp. The file will correctly be identified as a shapefile. Go to the next window. The Load As window correctly loads the shapefile as a vector, so go to the next window. Like the lakes, we'll have VNS name the vectors as they're imported. Make stream the name and click Next. The wizard is unable to glean a coordinate system from the shapefile, so the coordinate system editor pops up. Select Geographic NAD83 and close the editor. The coordinate system summary window will update with the new coordinate system. Continue to the next window. Under Shape Options, deselect the Assign DB Names from an Attribute field box. We'll let VNS assign unique names to the objects. We know the vectors aren't conformed and stream should be, so select Conform to Terrain. Import. The first Database Fields window wants attributes. Multiple select the Minor 1, Minor 2, and Order fields. The second Database Fields window is looking for database layer fields. Multiple select the Minor 1 and Order fields. After the data imports, the real-time views will refresh. Select an object in the database list and the title bar will update with a new total of 1203. Save the project. Let's create an easily identifiable stream layer. Select one of the stream vectors in the database objects list and search objects. Delete the number from the search string in the input request field and search. 873 stream vectors are selected. Go to the Layer page and add a layer. Enter Stream in the Input Request Layer Name field and enter. Now let's change stream vector properties by order and make them easy to identify in views. Recall that we imported both Minor 1 and Order attributes as layers. Order is a number from 1 to 7. A first-order stream is currently active, so activate the 1 layer and select Layer. Turn to the Properties page and change the color to 0 red, 0 green, and 255 blue. Return to the Layer page and activate Stream 10 in the Objects list. Activate the To layer and select Layer. Go to the Properties page and change the color to 0 red, 0 green, and 255 blue. Increase the line weight to 2. Change the style to dotted. Return to the Layer page and activate Stream 12 in the Objects list. Activate the 3 layer and select Layer. Turn to the Properties page and change the color to 0 red, 0 green, and 255 blue. Increase the line weight to 3. Leave the style at solid. Go to the Plan Default view and activate one of the Madison River vectors, which I know is an Order 4 stream, along here. It becomes active in the database as Stream 638. Select the 4 layer. Go to the Properties page and change the color to 0 red, 0 green, and 255 blue. Increase the line weight to 4. Change the style to dotted. Refresh the real-time views. First-order streams are thin, solid blue lines. Second-order streams are slightly wider, dotted blue lines. Third-order streams are even thicker, solid blue lines. Fourth-order streams are the widest dotted blue lines. No red stream vectors are visible, so it looks like we don't have any higher-order streams to worry about in this section of the park. Save the project. It looks like we have some vector overlap in the geyser basin view. You can see some red peeking through the left foreground lake vector. Go to the database editor and search objects. Enter lake into the input request search string field and search. Deselect the View checkbox. It appears that the stream shapefile we imported included some polygon entities. Activate the vector around Goose Lake. According to the database, it's Stream 799. The Attributes page lists a minor 1 value of 200. Revisiting the Entity and Attribute Information section of the metadata, we find that 200 is a shoreline. We could go through and remove all non-412 non-stream features, but it's not necessary. Once we disable them for rendering later on, they'll only show up in real-time views and the database. We're only interested in fourth-order streams in this project. First, we'll dig out Streambeds. Go to the Terrain task mode and add a Terraffector from the component gallery. Load the Big Muddy Riverbed and accept the Ecosystem Scaling option. Reset the Terraffector resolution. Rename it Stream Order 4. Edit cross-section profile. This riverbed is about 30 meters from center to bank, which makes it about 60 meters across. This is a bit large for our river. Reduce each point distance by a factor of 2. Select the second point from the center and change its distance to 5 meters. Go to the third point and make its distance 8 meters. Select the fourth point and make its distance 12 meters. Go to the fifth point and make its distance 13 meters. Change the value to 0 meters. Go to the next and last point and change its distance to 15 meters. Keep the changes and save the project. We have a Terraffector to dig out fourth-order stream beds. Now we need fourth-order vectors to place them on the terrain. Go to the Vector Placement section of the Terraffector editor, expand the Dynamic Link drop-down list, and choose New Search Query. Flip to the Search Query Selected Filter page. Expand the Attribute Field drop-down list and select Order. Make the order equal to 4. Go to the Search Query General page and select Items Now. The database editor will show 26 objects selected. The database editor attributes page for the last selected vector shows a minor 1 stream value of 412, a minor 2 value of 0, and an order of 4. It is possible that this shapefile makers assigned an order 4 attribute to a non-stream feature. Let's make sure that all the fourth order vectors in this search query are 412 streams. Go back to the search query and add another filter. Make this one Subtract Objects. Turn to the Selected Filter page and select Minor 1 from the Attribute Field drop-down list. Check Equals and Not. Enter 412 in the Value field. Return to the General page. This search query now adds all objects with a fourth order stream value and subtracts those objects that are not streams. Select Items Now. The database editor now shows only 23 objects selected, 3 less than the Add Only search query. Sure enough, somewhere among the fourth order objects are 3 that aren't streams. Just one more thing. If we don't have water in the intermittent lakes, we probably shouldn't have it in intermittent streams. Although it's highly unlikely that a fourth-order stream would be intermittent, it is possible that one of the vectors has a minor 2 attribute 610 value. Go back to the search query and add another filter. Make this one Subtract Objects. Turn to the Selected Filter page and select Minor 2 from the Attribute Field drop-down list. Check the Equals box. Enter 610 in the Value field. Return to the General page. This search query now adds all objects with a fourth order stream value, subtracts those objects that are not streams, and then subtracts intermittent objects. Select Items Now. The database editor still shows 23 objects selected, so we have no intermittent major rivers. Save the project. Let's add some water to the fourth order stream vectors. Go to the Water Task Mode and add a stream from the Component Gallery. Load the Big Muddy River. Reset the resolution and rename it Stream Order 4. We want this stream rendered along fourth order stream vectors, so expand the Dynamic Link drop-down list and select the Stream Order 4 search query. Go to the Water Material page and select the Depth tab. Water depth is set to about 0.3 meters below the controlling vector. Since the vectors are conformed to the terrain, this sounds like a good place to start. Open the status log and clear its contents. Save the project and render a geyser basin preview. Terraffector Streambeds and Streams have added an additional 304 megabytes of effects memory overhead, bringing the total to about 644 megabytes. Close the log. The water runs pretty clear in the river most of the time, so let's make it less muddy. First, we'll stop the stream vectors from rendering. Go to the Database Editor Layer page. Activate the Stream layer and select Layer. Uncheck the Render box. Go to the Stream Editor and open the Water Material page, Waters tab. Edit the diffuse color texture. In the Texture Editor, the color fractal noise element under F1 cell basis is the texture of the left color pin in the colors gradient. Activate it. Click the selected color well to open its color editor. Sample color from image. Click on Goose Lake in the Geyser Basin render to choose its color. Keep the new color. Slide the left color pin right to a gradient position of about 50% to increase the blue presence in the texture. Close the editor. Save the project and render another Geyser Basin preview.